what we have discussed till now, if we look at briefly, that we started with the ontological questions concerning the ways in which technology, science and society have been conceived of, the way the two important forces of production, namely science and technology, have been conceptualized, the relationship between technology and science, and there we have already discussed how technology is prior to modern science. I mean, technology always predates modern science. Okay. And then we have discussed the relationship between technology and science on the one hand and society on the other. And we have used three models of STS, three perspectives on STS: the linear or hierarchical model, the interactionist model and the embedded model. On the one hand, the linear model and the interactionist model treat science, technology and society as distinct entities, treat science, technology and society as separate entities, whereas the embedded model suggests that no, science and technology are not autonomous activities, are not isolated phenomena, are not independent activities, rather both science and technology are very much a part of our social formation. They are very much a part of our economy, culture and polity. This is very important. And from there on, staying with the ontological questions, what we have discussed, how the idea of technological determinism evolved, and how and in what ways we see some arguments against technological determinism, and how technology is not neutral. Anyway, we will discuss this in the following lectures sometime later in the week, but what we found that the neutrality of technology is contingent upon the way a specific technology is designed and controlled. And whether a technology is neutral or not, we provided certain examples from the construction of the New York Bridge, from the design of the public roads in India, that technology is not neutral. Okay? Whenever we talk about technology, we must talk about technology vis-a-vis the nature of the state and the kind of public policies that the state is going to have. Okay? This is very important. In this kind of circumstance, from these ontological questions, we moved to the normative questions, because the reality suggests that these changes, changes in the relationship between science, technology and society, okay, have significant implications on agriculture, on health, on environment, on social security measures and so on. And in this context, we thought, okay, now from these ontological, from the questions concerning reality, okay, what it ought to be, what kind of STS we want to, I mean, what should be the form of STS, what should be what ought to be the practices of STS. And from there onward, we started a detailed discussion on Mertonian institutional imperatives in the form of Mertonian ethos of science, ethos of modern science. I mean, ethos of modern science, when I say effectively toned complex of values and norms which is held to be binding on the man of science. And these norms are expressed in terms of prescriptions, proscriptions, preferences and permissions. We have already discussed this. Merton also dwelt upon the goal of science as the extension of certified knowledge and the imperatives of science which are derived from the goal and the methods, and then he moved to flag 4 institutional imperatives, 4 ethos of modern science in the form of universalism, communism, disinterestedness and organized skepticism. If you look at this, then what we find that universalism, communism and disinterestedness, they come under the rubric of the goal of science, whereas organized skepticism comes under the methodological rationale of science. And from this, if the reality suggests something and the normative questions, the normative structure of science suggests something, then what should be the methods of science? And the methods that we have tried to delineate, okay, within methods of science we have discussed inductivism, hypothesism, okay, or positivism, then the methodology provided by Karl Popper. In the lectures to follow, what we are going to discuss, we are going to discuss the methodology propounded by Thomas Kuhn and Paul Feyerabend. It does not imply that the methods of science, the debate concerning the methods of science ends here. The debate does not end here. The debate is still on. Okay? And the question, the method, what is the method of science, is as old as science itself. Okay? The question which was addressed, the question what is the method of science was addressed by Aristotle. Aristotle tried to provide a satisfactory answer to this question. Okay? And if you look at the history of science, for 3 centuries, from 17th to 20th centuries, okay, 2 methodologies became standout performers to the question which was posed, to the question what is the method of science. And then those 2 rival methodologies, those 2 rival responses to this question what is the method of science, consist of inductivism and hypothesism. And as we have already discussed how inductivism is rooted in empiricism, empiricism is rooted in experience, whatever we cannot observe, okay, cannot be considered knowledge in the inductivist schema. Okay. Knowledge is generated only through observations, okay, which Bacon propounded, okay, Francis Bacon, the father of empiricism, inductivism. On the other hand, what we saw during these 3 centuries, hypothesism, which was propounded by René Descartes. Descartes is also known as the father of rationalism. Hypothesism is grounded in the principles of rationalism, in the philosophy of rationalism. Rationalism is based on reason, according to which knowledge is generated only when we go beyond observation, whereas inductivists argued that knowledge starts with, science starts with observation, begins with observation, remains at the level of observations and ends with observation. Hypothesists argued that no, science starts only when we go beyond observations. That's how science is trans-observational in nature. Okay? Whereas inductivists looked upon certainty and breadth as the hallmarks of scientific knowledge, hypothesists looked upon novelty and depth as the hallmarks of scientific knowledge. Okay? We have already discussed this. I am just trying to recapitulate whatever has been discussed. Then the question emerged that, that how to mediate the two, inductivism and hypothesis. And the 20th century saw the emergence of positivism as the most or one of the most dominant schools of philosophy of science. If you look at the annals of history of science, then you will find the way they tried to develop their perspectives on the development of society, okay, namely the theological stage, the metaphysical stage, the positivistic or scientific stage. And positivism stood squarely against the schools of theology as well as metaphysics. As we have already discussed, theological stage was more concerned with the changes which occur due to supernatural forces, whereas metaphysical stage attributes or metaphysical stage attributed changes mediated by natural forces, and positivists suggested that no, or positivists or the proponents of positivism or scientific stage suggest that no, changes occur not because of supernatural forces or only natural forces, but because of the human action. That is why positivism emerged in the context of the context of the emergence of enlightenment, industrial revolution, okay, critical thinking, rationality, I mean rationalist philosophy of science, modernity and so on. If you look at this, positivism also tried to question the dominance of church, okay, which both theological stage and metaphysical stage could not do. I mean they believed in the dominance of religion, especially the dominance of church in Europe, and positivism was the first stage in the annals of the methods of science which tried to question the dominance of religion. Okay? That is why positivism provided several tenets, and positivism perhaps was the first organized method of science which tried to look at science as a paradigm of knowledge, okay, separated from or distinct from other areas of human activity or creativity. Okay. That is why the first tenet, if you slightly recall, the first tenet suggests that the method of science is, I mean that science is distinct from all areas of human activity or creativity because it possesses a method unique to it. Okay. We have discussed many tenets that that there is only one method common to all sciences irrespective of their subject matter, that is methodological monism, that the method of science is the method of induction, that is inductivism, that that the hallmark of scientific knowledge consists in the fact that all scientific statements must be systematically verifiable, that is systematic verifiability, that there must be a dichotomy between fact and value. Facts do not have value, facts are value neutral, whereas values do not have factual content. There must be a unilateral relationship between observation and theory. Then we came to a critique of positivism, that no observation is presuppositionless, no observation is theory independent. As positivists argued, observations are always theory laden, because the way we discussed, I mean observation does not provide us with a language or idiom for expression, whereas theory provides us with a language or idiom for expression. Okay. In the context of observation, whether observations presuppose theory or not, we discuss. Then if no observation is presuppositionless. If science does not start with observation, as inductivists as well as positivists argued, such systematic rejection or systematic critique of positivistic construal of science was brought about by Karl Popper. And there we have already discussed how Popper started with posing this question, what is the central question of philosophy? That is the problem of cosmology. What is the problem of cosmology? Now, the problem of understanding the world, including ourselves as part of the world. If we get isolated from the world, then we cannot examine the world, we cannot understand the world. To understand the world, we must be a part of the world, we must involve ourselves with the real world phenomena. Then Popper argued, Popper immediately tried to delineate the method of science by making a reference to the context of justification, and he refused to talk anything about the context of discovery, because for him, for Popper, context of it is impossible, it is not possible to provide a rational account of context of discovery, okay? And he always sided with the context of justification while providing an explanation. For Popper, science cannot start with observation as inductivists or positivists argued, or science also cannot start with a hypothesis as hypothesists argued. For Popper, science must start with a problem. If there is no problem, then what kind of observation that you are going to make? Because whatever observations that we make, our observations must involve some element of selection, some amount of selection, and that selection is very important. Why do we make how is knowledge generated in the domain of science? For Popper, precisely because if my observation and my expectation coincide, then we are not going to generate science. If our observation and expectation, they do not coincide, if my expectation deviates from the kind of observation that I am making, okay, then there is a scope of knowledge production. In this context, Popper's view is extremely important to note that that science must start with a problem, with a research question. Science must be able to identify a problem. From that problem, we must try to formulate a hypothesis, which is a tentative solution to a problem or hunch. From the formulation of hypothesis, the way hypothesists argued that it must be tested right or wrong, and if a hypothesis is tested wrong, then it must be rejected. If a hypothesis is tested right, then it must be accepted. But for Popper, this hypothesis may not be tested right or wrong, but a hypothesis must be falsified. So, I am just giving you one more cue that as we have already discussed, that you see a hypothesis need not be proved or disproved. If one is die-hard in proving or disproving his or her hypothesis, then it hinders the tradition of cumulative knowledge production. One must remember this. Then a hypothesis must be tested right or wrong in the hypothesis schema. For Popper, it must be falsified. It must go through the process of systematic falsification. If the hypothesis must go through the process of systematic falsification, then it may run the danger of it may be again falsified, it may be tested again right or wrong. But if it is tested wrong, then it runs the danger of refutation. Okay? It must be subject to refutation. We must refute that, we must reject that hypothesis. On the other hand, if our hypothesis is tested right, hypothesis would have argued that let us accept our hypothesis. For Popper, no, let us not accept our hypothesis, rather let us corroborate our hypothesis. Let us keep our hypothesis permanently tentative. By doing that, Popper meant that under certain limiting conditions, we are trying to corroborate or we are trying to keep our hypothesis permanently tentative, because we have not yet been able to explore all, we have not yet been able to explore all conditions, as well as we have not yet been able to test our hypothesis under all other conditions. Okay? That is why there is the question of universality, okay, was interrogated by Popper. That is why the question of truth was interrogated by absolute truth. That is why he used the term verisimilitude, very close to the truth, or truth likeness or truth nearness. Okay? That is why, what is that verisimilitude? No, that the distinction between an existing theory and a better theory. And for Popper, a better theory has the characteristics of, has the tenets of verisimilitude. It is closer to the truth, but it is not the truth in itself. Okay? And such characterization, such delineation of Popperian methodology, okay, was also questioned by many authors. In fact, Popper had as many critics, as many number of critics you will see, and you will also find similarly he had many admirers. Okay? If Popper's method of systematic falsification provided us with a paradigm in the method of science in the second half of the 20th century, then one of his perhaps the greatest rivals who emerged in the form of the structure of scientific revolutions, namely Thomas Samuel Kuhn. And these two, both Popper and Kuhn, they perhaps if you look at the works of Steve Fuller, if you look at the school, the Edinburgh school, Latour, Bourdieu and so on, okay, you will find that the controversies, the debates aroused in the context of the methods of science by both Popper and Kuhn is interesting. They are interesting to learn, precisely because they provided two different methods which cannot be refuted on their own, at least today. Both of them are no more, but we still celebrate their works as quite novel works, perhaps quite original works in their own right. Okay? Having dwelt upon Popperian methodology and the kind of critical remarks that we made through the works of N.R. Hansen in the last lecture, let us briefly look at the views of Thomas Samuel Kuhn, if you look at this. Okay? Kuhn, his magnum opus work, the structure of scientific revolutions in 1962, okay, constitutes a turning point in the 20th century philosophy of science. Before we comment on the radical ramifications of Kuhn's views, a brief exposition of his fundamental ideas must be put in place. it is important to know under what circumstances Kuhn was writing, what kind of transition that science always makes or has already made, okay, must be understood critically. Okay. And Kuhn provides with that kind of paradigm. For Kuhn, according to Kuhn, okay, the life of every major science passes through two stages, two successive stages, which may be characterized as pre-paradigmatic stage as well as paradigmatic. During the pre-paradigmatic period of a science, one finds more than one mode of practicing that particular science. Thus, there was a time when there were different schools in astronomy which practiced astronomy differently. So, was the case with disciplines like physics, chemistry and biology too. Their situation at that stage of their development was similar to the one which obtains today in the case of creative areas like art, literature, philosophy, history, even sociology and even medicine, okay, wherein different divergent modes of practicing these disciplines coexist. Why is it so? Earlier, there were various schools of astronomy, there were various schools of physics, there were various schools of chemistry, there were various schools of biology. But today, if you look at this, they are trying to build a consensus within these disciplines, okay, for Kuhn, okay, which creative areas like art, literature, philosophy and even medicine, okay, they are not able to create that kind of consensus, precisely because of the kind of because of the nature of the problems that we are endowed with. Then because that's why what we find today, that perhaps in in the context of astronomy, physics, chemistry, biology, okay, you find some kind of a thinking or some kind of a convergent thinking, whereas in the creative areas like art, literature, philosophy and even medicine, what we generally find, there are divergent modes of practicing these disciplines. I mean, in medicine you find allopathy, you find Ayurveda, you may find homeopathy, you may find Unani, you may find naturopathy. Okay? There is no consensus. Okay? But in the case of astronomy, there is a consensus. I mean, today there is a consensus. Suppose I will say that earlier notion, as we have already discussed in the context of Ptolemy prior to Copernicus, okay, you will find that the sun rotates, okay, and the earth remains constant. That is Ptolemaic version of astronomy. Ptolemy was also influenced by the powers that be at that time, whereas Copernicus and subsequently Galileo, they tried to convince, they tried to foreground the fact that no, the sun remains constant, okay, rather the earth rotates, moves around the sun. In this context, we have come to a point of a convergent thinking in the field of astronomy. But in the field of medicine today, we do not have convergent thinking, rather we have divergent thinking. In the context of literature, in the context of art, in the context of music, in the context of philosophy, in the context of history, we have divergent modes of practicing. Okay? That is why, whereas even today we speak of schools of art, schools of literature, schools of philosophy and systems or schools of medicine, we do not speak of schools of astronomy, schools of physics, schools of biology, etc. This is because according to Kuhn, areas like art, literature, philosophy and medicine did not and perhaps cannot come to a point of convergent thinking, cannot make a transition from pre-paradigmatic stage to a paradigmatic stage. Then if I say if I go ahead with Kuhnian version of paradigmatic shifts, then I must make a reference to the fact that in the pre-paradigmatic stage we found divergent thinking, whereas in the paradigmatic stage we find convergent thinking. Okay? That is why according to Kuhn, creative areas like art, music, literature, philosophy and medicine did not and perhaps cannot make a transition from pre-paradigmatic stage to paradigmatic stage. So, what characterizes a science which enters the paradigmatic stage is the disappearance of schools. Those divergent modes of thinking must disappear, okay, in the context of a paradigm. Okay. That is why they try to build a consensus. Okay. What is a consensus? We will come to this a little while later. If what characterizes a science which enters the paradigmatic stage is the disappearance of schools, okay. In other words, the transition from the pre-paradigmatic stage to the paradigmatic stage implies the replacement of plurality by uniformity of practice. Now, in astronomy, now no astronomer would tell you, okay, that the earth remains constant and the sun rotates, the sun moves around the earth. Okay. Now, they have come to a point of convergent thinking that no, their opinion is uniform now, uniformly based, okay, in the Kuhnian schema, that the transition from pre-paradigmatic stage to the paradigmatic stage implies the replacement of plurality by uniformity of practice. The transition from the pre-paradigmatic stage to the paradigmatic stage implies the replacement of divergent thinking, okay, by the convergent thinking. Okay. That is why replacement of plurality by uniformity of practice. Okay. Whereas, or when a science reaches the paradigmatic stage, it becomes, according to Kuhn, mature, or science in the present sense of the term. It becomes mature. Okay. And if I say that a science would make a transition from pre-paradigmatic stage to the paradigmatic stage, or which discipline was the first to make a transition from pre-paradigmatic stage to the paradigmatic stage? Now, astronomy was the first to enter the paradigmatic stage, followed by physics, then chemistry and then biology. Social sciences, I mean including sociology, which I hail from, okay, as a student of sociology, okay, I would always say, even Kuhn also suggested that social sciences are very much in the pre-paradigmatic stage, since they have not yet succeeded in bringing about consensus over their practice, as is shown by the prevalence of schools in social sciences. Creative areas like art, literature, music, philosophy and so on perhaps can never reach the second stage, precisely because of the nature of the problems that we are confronted with today in social sciences, in humanities. Okay? Perhaps, but that is a different question, whether we should have a consensus or not. Is it an ethical question or not? That is a different story altogether, okay, in today's context. Okay. Perhaps divergent thinking in social sciences is preferred. Okay. but that is not there in the Kuhnian schema as such. Okay. We will come to this point. Okay. Then what kind of mature science that we talk about? A science thus becomes mature when it acquires a paradigm. I mean, science becomes mature when it makes a transition from pre-paradigmatic stage to the paradigmatic stage. It is the acquisition of a paradigm which replaces plurality by uniformity of practice. It is the acquisition of a paradigm which replaces divergent thinking by convergent thinking. Then what are these paradigms all about? What do we know or what do we mean by paradigms? Okay? We all, suppose if you look at different disciplines, suppose we have discussed that in the Kuhnian schema that we have made a we have made a statement that astronomy was the first to make a transition from pre-paradigmatic stage to a paradigmatic stage, followed by physics, then chemistry and then biology. Then what kind of paradigm that they have created? If you look at this, we all know that Ptolemy's Almagest was a paradigm in astronomy. Later on, we say Copernican revolution is a paradigm in astronomy, okay, when Ptolemy was rejected. Newton's Principia was a paradigm in physics. Now we say no, Einstein's theory of relativity is the paradigm in physics. But today perhaps till now we haven't yet been able to come up with any alternative, but Darwin in the field of biological sciences still rules the roost. Darwin's The Origin of Species. Then we all know that Ptolemy's Almagest, initially Newton's Principia and Darwin's The Origin of Species are path-breaking works in the areas of astronomy, physics and biology respectively. According to Kuhn, these works provided paradigms for these disciplines, and they did so by specifying the exact manner in which these disciplines ought to proceed. They laid the ground rules, okay, laid the foundations regarding what problems these disciplines must tackle and how to tackle them. Then a paradigm, a paradigmatic discipline, a paradigmatic work must not only attempts to identify problems for their respective disciplines, but also must be able to show how to address those problems, how to answer those problems, okay, how to tackle them. Hence, then what are paradigms theoretically? Then for Kuhn, let me quote Kuhn here, paradigms are universally recognized scientific achievements that for a time provide model problems and solutions to those model problems to a community of practitioners. It not only provides model problems, but also provides solutions to those model problems to a community of practitioners. In the case of in this case, to a community of scientists. Okay? Let me break this statement of Kuhn, definition of Kuhn, the way he delineated. Okay? First, a paradigm specifies what the ultimate constituents of that sphere of reality which a particular science is inquiring into are. Secondly, it identifies the model problems, model questions. Thirdly, it specifies the possible range of solutions to those model questions or model problems. Fourthly, it provides the necessary strategies and techniques to solve those problems, I mean methodologies. Okay? Finally, it provides examples which show how to solve those certain problems. In other words, a paradigm is a disciplinary matrix of a professional group. Then we must discuss one by one. Number one, a paradigm specifies what the ultimate constituents of that science of reality which a particular science is inquiring into are. I mean the entire subject matter of that science must be known. The scope and ambit of that particular science must be known through that paradigm. And for a long time Ptolemy's Almagest in fact provided us with that. Copernicus later on provided us with that. Then Newton also, I mean Einstein, Darwin. Okay. Then that particular paradigm, perhaps suppose Darwin's the origin of species, evolution of species, principle of natural selection. Okay. That paradigm tries to identify the model problems. What are the model problems? Suppose if I say, let me give you an example that if I say dinosaur, anaconda, they were far more powerful compared to human species like us. So, if you look at their energy, if you look at their stamina, way they have that, they possess that killer instinct. Okay. I mean, they could have survived. Why they could not survive and human species survived? Okay. Darwin provided a satisfactory answer, later on Marx provided a satisfactory answer, and other biologists they also have provided satisfactory answer to such question. Number one is adaptability. A species, howsoever may be huge or small, okay, that species must be able to adapt to the existing environment, nature, number one. And number two is that power to reproduce further. I mean, you have to further your generations. Okay. In those two cases, okay, Darwin principle of natural selection, if you look at this, I mean, this is how we have survived. Okay. Human species have survived. Okay. These are the model problems that Darwin provided, principle, and also the kind of model solutions to those model problems. Okay. Within that specific discipline of biology, he also provided principle of natural selection. Okay. Fourthly, a paradigm must provide the necessary strategies and techniques for solving those problems. I mean the particular paradigm must be able to provide the necessary methods, methodological framework, must formulate a proper methodological framework to solve those model problems. And finally, a paradigm must provide examples which show how to solve certain problems. That is why perhaps Kuhn mentioned that a paradigm is a disciplinary matrix of a professional group. In this context, professional group, I mean the scientific community. Okay? I mean, there is no individual scientist here, but the collective scientific community on the whole. Once a science matures, once a science comes to possess a paradigm, it develops what Kuhn calls normal science studies. This is a normal science. Normal science does not mean normal or abnormal science, I mean norm bound science, which are bound by rules, regulations, values, institutional mandates, normative framework of science. Okay? Then what is that normal science? Normal science is the day-to-day research activity purporting to force nature into conceptual boxes provided by a particular paradigm. And the practitioners of normal science, that is scientists themselves who are engaged in day-to-day research, internalize the paradigm by professional education. And such professional, I mean this internalization of the paradigm by professional education explains the prevalence of textbook culture to science education. Okay? That is norm bound science, value based science. You cannot deviate from the rules and regulations of science. Okay? That is normal science. You cannot deviate from the norms. You cannot go beyond the norms. You have to operate your practices, you have to carry out your experiments within certain norms, within certain rules, regulations, frameworks, institutions, structures, organizations, mandates, and so on. Okay? And from here onward, what we see, okay, what kind of normal science then we are talking. Indeed, scientific practices are not exhausted in terms of day to day research or normal science. When a paradigm fails to promote fruitful, interesting and smooth normal science, it is considered to be in a crisis. And the deepening of the crisis leads to the replacement of the existing paradigm by a new paradigm. That is why paradigms are also not static. The existing paradigm may become a pre-paradigmatic stage for a new paradigm. Okay? They are not static, they are quite dynamic. I mean, paradigm means model. Models are not static. Models change with the changes in the questions, the problems, the circumstances, conditions, and so on. Okay? That is why when a paradigm fails to promote fruitful, interesting and smooth normal science tradition, it is considered to be in a crisis. The deepening of the crisis leads to the replacement of the existing paradigm by a new paradigm. And this process of replacement of the existing paradigm by the new paradigm is called scientific revolution. I mean, you may say revolutionary science as against normal science. Normal science is norm bound, institution bound, rule bound, regulation bound, but in the context of revolutionary science, it goes beyond norms. Had there been no revolutionary science, there would not have been Copernicus. Had there been no revolutionary science, there would not have been any Einstein. Had there been no revolutionary science, then there would not have been any Darwin. Otherwise, everybody used to, now everybody thinks, prior to Darwin, there was thinking that, prior to Marx also, people used to think that, how have we, there was a theological explanation that gods and goddesses have created us. Such questions were raised, such questions were challenged, such propositions were challenged, okay, by Darwin initially and then subsequently Marx and so on. Okay? That is why Marx once wrote, Darwin has made God redundant, okay, in the context of the origin of species, in the context of the principle of natural selection. Okay? That is why this process of replacement of the existing paradigm by a new paradigm, okay, is also called scientific revolution or revolutionary science, you can say. Therefore, scientific revolutions, if I say if normal science is, which is a puzzle solving activity, which is a day to day, which refers to a day to day research activity, okay, if normal science is the tradition bound activity, then revolutionary science is the tradition shattering activity. Therefore, scientific revolutions are the tradition shattering complements to the tradition bound activity of normal science. Thus, once a science enters the paradigmatic stage, it is characterized by first normal science and second revolutionary science. I repeat, if normal science, the way it is known as a puzzle solving activity, the way we know that normal science is a day to day research activity, norm bound activity. If normal science is refers to a tradition bound activity, then revolutionary science is the tradition shattering activity. It does not follow tradition, it goes beyond the hitherto existing traditional norms, institutional frameworks, structures, organizational mandates and so on. Okay? That is how science makes progress. In sheer temporal terms, normal science occupies much larger span than does revolutionary science. That is to say, science is revolutionary once a while, and mostly it is non-revolutionary or normal that we find. Okay. Also, the scientific activity engaged by most of the practitioners can be characterized aptly in terms of the in terms of normal science. Because of this temporal and numerical magnitude, we can say that much of the scientific activity as we ordinarily encounter is normal, though this normal course is occasionally interrupted by revolutions which change the form, content and direction of the process of the scientific activity, which is basically normal, by which we mean non-revolutionary committed and tradition bound activity. That is why normal science is always tradition bound activity, whereas revolutionary science is always tradition shattering activity.